Okay, so do you agree on this one? You had the factor first. You with me? All right, so you should have been taken a parabola and reflected it down, and then shifted right 1 and up 3. Now I'm going to try this a different way that seems to work a little better yesterday. Today we're going to try doing the stretch and reflect first, then the shift, and I think you'll do better that way. It's a little easier to find those essential points when you do it that way. So hopefully that'll work. So if I do that in this sense, just to kind of start to get you thinking that way, that negative, it's on the x, so does it reflect it right, left, or up, down? If it's on the x, it changes x, so it reflects right, left. Right, now do you agree a parabola reflected right, left looks just like it would? Okay, now that negative outside the function changes y, so that reflects it down, all right? So I did my reflections, now I'm ready to shift. I'm at this point now. How does it shift? Right 1, up 3, right 1, up 3, boom, there's the critical point, 1, 3, all right? Again, not because I'm going to show it every time, but for the y-intercept. To find the y-intercept, what do I put in? X equals 0. If you put in x equals 0 into, the question I get is, a good question is, which should I put it into? The new one or the original? You should always put in the original. Now, the reason is, if you made a mistake going from here to here, if you put in here, you're not going to catch that mistake. You catch that mistake by going to the original. So by putting it into the original, you're checking all of the. So if you put 0 into your original equation, you get negative 1 plus 3, which is 2. Now, in terms of grading this, 1 point, I'm going to cut you some major slack here. 1 point is if you have the shape right. If you have some parabola shape anywhere, okay? 1 point is for the 2 essential points. So do you have the 1, 3 and the 0, 2? If you have both, just write nothing. If you don't have the points right, call it minus 1. Is it clear what I want you to do? Okay, cool. With this then, when you shift, or when you factor rather, isn't a cube shape this kind of frowning down, frowning up kind of, or frowning up, smiling up kind of shape, yeah? In calculus, that's called an inflection point. So if that negative comes along, what kind of reflection does a negative on x do? Left, right. So that would make it left, right then is now. But then what does that negative do? Flex it down. Doesn't this reflected down look right back to where it was, yeah? All right, then again, it's right 1, up 3. So that bend point, the inflection point it's called, that middle of the curve where it changes from frowning to smiling is 1, 3. And again, when you put in x equals 0, you get y is negative 1 plus 3, or 2. So if you have the right shape, that's 1 point. If you have the right critical points, that's 2, the other point. Stop me, shout out if you have any questions, please. Cool, let's move along. Okay, this was a bit of a doozy. So when you factor, check that you factored right. What does negative do? Reflect left, right, or reflect up, down? That negative is inside with the x, so it reflects it left, right. All right, so that would normally look like that. And now it's going to reflect left, right. It's going to look exactly the same. What does the fact that it's 2 do? When you multiply by 2, does that shift or stretch? Stretch. It'll make it vertically stretched or horizontally squished. It looks the same either way. So instead of this wider V, it's a narrower V. All right, cool. I have the coefficient part done. Now I do the shifts. What are the shifts? Over 2. Give me more than over. Right or left? Right 2, down 1. So that puts the bottom of the V at 2, negative 1. And the y-intercept, what'd you get for y-intercept? 0, 3? Okay. So, again, if you have a V, that's 1 point. If you have the correct location, then that's the other point. Square root graph as you see it. 3 causes it to horizontally squish, or you could say vertically stretch, and then it's left 3 down 1. So you should have the right shape is 1 point, and then -3, -1 for the essential point, and 0, 2 for the y-intercept. 5, factor first. You factor out a -3. The negative causes it to reflect sideways. The 3 causes it to be stretched or horizontally squished. So at that point then I've gone from here to here to here, so it's more steep going, and then it's shifting it right 3 down 1. So check the shape, and is it in the correct points? Your point should be 3, -1, and 0, 2. Cool? All right, this guy, I just redraw my origin. If it's shifted left 3 down 2, then my new origin goes from the origin to 1, 2, 3 left 2. There's my new origin. And then this should be, let's go 1 point for the graph and 1 point for the asymptotes. If you just have -2 and -3, that is not okay. It was wrong, mark them wrong. Please do in your pen write in x equals or y equals, so in the future you know what you did wrong. All right? Number 7, these are killing me. Killing me. All right. I have students that can't graph exponentials and logs. I'm not talking shifted, just basic. So we're going to do as many of these as it takes. If I have to do 100 of these every day, so be it. But you're going to get this, or it will kill one of them. So y equals 2 to the x. Give me a point. 0, 1, or 1, 0? 0, 1, because 2 to the 0 is 1. Give me another point. 1, 2. Okay? 3 to the x. Give me 2 points. 0, 1, and 1, 3. Boom. 4 to the x. Give me 2 points. 0, 1, and 1, 4. Cool. Give me y equals base to the x. Give me 1 point. 0, 1, and give me another point. 1 base. It's not tricky. It's always the same. It's the same 2 points. 0, 1 is on all of them, and 1 base is on all of them. So e to the x, give me some points. 0, 1, and 1e, which is about 2.7. All right. Now, some of you are definitely freaking yourself out on the logs, thinking way too hard. All you're going to do is take all of those points and switch them. The log is the switching of the exponentials. So instead of 0, 1, when I go to graph log base 2 of x, instead of 0, 1, I have 1, 0. Instead of 1, 2, I have 2, 1. Okay, for log base 3 of x, instead of 0, 1, I have 1, 0. And instead of 1, 3, I have 3, 1. Log base 4 of x, instead of 0, 1, 1, 0, instead of 1, 4, 4, 1. Generally, y equals log of some base to the x. What is 1 point that's on all of them? 0, 1, 1, 0. And the other point is, instead of 2, 1, 3, 1, 4, 1, it's base 1. Boom. All right, so what about natural log, which is log, like log base e? What are the points? 0, 1, or 1, 0? 1, 0, and e1. Okay, now then, with that in mind, we know that y equals 2 to the x has the point 0, 1, and 1, 2. What does the 3 do? Moves it down 3. So this point that was at 1 goes to 1, 2, 3. It ends at -2. So you should have a point at 0, -2. And this point that was at 1, 2. Let's think logically. I could either count spaces. Now, unfortunately, it's not on grid, so it's hard to count spaces. So instead, let's just think about it. When I move it down 3, does that change x? No, if you move it down, the x is exactly the same. But what about the y? Does the y change? So if I have a 1, 2, and I subtract 3 from the y, that puts me at 1 and -1. Those are your critical points, and then the asymptote is y equals -3. This is 1 point for the graph, 1 point for the asymptote, and 1 point for the points, 3 points altogether. All right? This then is right 3, so instead of these points, I'm going to move them right 3. If I take the 0, 1 point and move it right 3, what changes? The x or the y? X. So instead of 0, 3, it goes to, or sorry, instead of 0, 1, it goes to 3, 1. This point was 1, 2. We're shifting the x, adding it to 3, so it changes to 4, 2. So your points are 3, 1, and 4, 2. The asymptote is exactly the same, y equals 0. And then the graph you can see. 3 points, mark off for anything you missed. These then are starting to get a lot harder because they involve reflections. This is y equals 2 to the negative x minus 2 when you factor. Do you agree with that factorization? Let's do this rather than, this is partially my fault. I thought it would be easier to have you shift first. It wasn't, it was a disaster. So let's go through this a little differently. Do you agree with my basic graph before changing it? Okay, now let's first, I told you before, we're going to start to do the stretches first, or reflections first. So what does that negative do? If it's a negative on the x, it reflects it side to side or up and down? Side to side. So now the graph is going to be here, and that point now will be at -1, 2 rather than 1, 2. Then what does the 2 do? Moves it right 2, and this point moves right 2, so your graph should look like that. The critical points are 2, 1, and 1, 2. The asymptote is still at y equals 0. Again, if you're just writing 0 for these asymptotes, you're going to be hurting because that is going to be wrong. Every asymptotes are equations. All right, -2x plus 1 minus 3. This is a bit of a humdinger. Here's 2 to the x. What is that? Again, I'm going to do the negatives first, then do the shifting. So what does that negative do? Flip it down or flip it over? Flip it down. So it's going to go like this here. Then what does the 1 do? Moves it left 1. And then what does the 3 do? Down 3. So 1, 2, 3, down 3 goes to the point. Ooh, I only have 1 point. -1, -4, and 0, -5 with y equal -3. All right? Is the asymptote. Log base 4 of x, that's not even changed, so that's the basic points of 1, 0, 4, 1. If I throw a negative on the x, it reflects it over the x-axis. So that's -1, 0, -4, 1. All right. Boom, negative log base 4 of x plus 2. This negative, instead of being like this, will cause it to reflect this way, then shift it up to, so that's where we're coming from here in the black. Your critical points, the graph looks like that, and your essential points are 1, 2, 4, 1, and x equals 0. This is left 2, so if you take the graph, reflect it down, then go left 2, then you should have an asymptote at x equals -2, and your essential points are -2, -1, -1, 0. And finally, Tangent, remember, is sine over cosine, so it goes through the origin. Because when sine is 0, we get a 0. Cotangent is cosine over sine, so when sine is 0, or when the angle is 0, sine is 0, that's got an asymptote. Cotangent has an asymptote at pi and 0 and so on. Bends, tangent bends to the right, and yep. So it's 1, 1, 1. Let me know when you're ready. Okay. Okay. 17, factor and solve. Let's just go all or none on that. Pi over 4 and 5 pi over 4. This one, yeah, should we go one for the solving and then one for, yeah, let's just go one. Okay, so same deal on 18. You had to solve the quadratic, then you had to solve the trig. Your quadratic solution should be negative 1/2 and 1, so that when you solve the trig, sine would equal at negative 1/2 at 7 pi over 6 and 11 pi over 6, and would equal 1 at pi over 2. Cool? Arcsine of negative root 3 over 2 is negative pi over 3. Our cotangent of negative root 3 over 3 is, oh, it's up there, 2 pi over 3. Follow? Test 9 number 9 is 0. Test 9 number 10, A is root 2 over 2. And B is root 3. I didn't think we had those on here. Did those go okay? How'd those go? Yeah, have we done anything like that before? All right, so the idea is work inside out. So start by saying at what angle is tangent 1, which is pi over 4. If that's pi over 4, then you do the sine. So work inside out. Okay, yes?
For number 19, 20, didn't specify that it was in radians, so you put it in degrees.
Yes, that's fine. If you have negative 60 degrees, that's fine, and 120 is fine. Yeah, absolutely. Thank you. Yes?
Can you number 10, is it like all just one point?
It is 1. The reason is that inverse trig or arc trig should only be 1. So if only one angle goes into sine or tangent, then you should only get one answer.
Like I got A, but it get B.
Oh, I see what you're saying. I'm sorry, I misunderstood. Let's go 2 points there. They're pretty high-level thinking. All right. Test 9, number 18. Let's call this 3 points as well, one for each part. X equals 3/4 for A, X equals negative 3 for B, and X equals 81 for C. Say again. 1 over 81. So would you agree that this means 1/3? If you actually, let's think of it this way. You want to get rid of log base 1/3. So what's the opposite of log base 1/3? Not 3, but 1/3 2. Isn't the opposite of log exponential?
Isn't it just like 1/3?
1/3 to the negative 4.
Yeah.
So 1/3 to the negative 4 means reciprocal. So I think that's why. If you thought it was x, then that's why you got it. Yeah. Or I mean, if you thought it was normal 4, that's probably why you got it. Okay. Number 10, number 20 is 10, and test 10, number 10 is also 10. Is that all? Nope. Test 10, number 11 is 5. Test 10, number 12 is 2. Notice how when you fourth root it, you get plus or minus, but you can't put negatives into logs, so it's just 2. It is wrong if you put plus or minus 2. Test 10, number 13 is negative 4, because 3 to the negative 4th power would be 181, 1 over 81. And then last but not least, T10 number 14 is this big mess. The 3 parts are 1/2, negative root 2 over 2, and minus root 2 over 3. Yes? 12? This one or the previous? Which one? Oh. Uh-oh. Uh-oh. I just destroyed my board. The log graph? This one? Okay, you bet. Okay. So total up how many minus ones you got on your paper and pass it forward. And then get out your essential gold sheet. Your never lose it. Guard it with your life sheet. Thanks, pal. I got yours. How many? That's all the best friends. All right. Thank you. Maya. All right. I'm good. Okay, get out the gold, please. And let's go. Gold. The gold sheets. So, this is meant to be a study guide to help you for the test next week. You're not going to use it on the test, but it's definitely meant to be your parent curves, your basic shapes. Would you give me the essential point on number 1? 0, 0. What about on y equals x cubed? 0, 0. What about on the absolute value of x, which is a v? 0, 0. And that's all. What about on a to the x? There's 2. 0, 1, and 1a, or 1 base, if you like, whatever you prefer. Okay? The base is a, obviously. Y equals e to the x. 0, 1, and 1e. Natural log of x. 1, 0, and e1. Would you just throw off to the side there a little bit? Let's call it 6b. Y equals log base a of x. What's the shape? Over there, for Pete's sake, you just took 100 of them. Okay, what are the critical points? 1, 0, and a1. Okay. Going back to your regular old sheet, what's the essential point to square root graph? 0, 0 for the starting point. 1 over x has p asymptotes. What's the equation of the horizontal asymptote? There's an equation. Y equals 0. I know it's the x-axis, but y is always 0 there, not x. What about at the y-axis? X is always 0. Okay, that has asymptotes. And then tangent and cotangent, sine and cosine, we just put on for your enjoyment or your reminder. But remember, why does it have asymptotes at all? It's where cosine is 0. That's where you have asymptotes, where cosine is 0. Okay? Whereas cotangent has asymptotes where sine equals 0, so that's 0 and pi. So, all right, they're not axes. All right. And then there's some cosines and sines and secants kind of roughly or really lightly drawn in there. All right, now then, let's get some killing done here in a good way. We're going to do examples A, B, and C together, and then you're going to just kind of do one and we'll check it together. And do one and check it together. All right, so here's the deal. On A, what do you got? What are you going to do first? Factor. And when I do, if I take out a, what do I take out a? Negative 2, leaving me with x minus 3. Okay, now this is where you're going to use your arrangement. Right? So what's the shape of x cubed? squiggly line that goes from frowny to smiley, like you when you won't come into class, right? And then what does the negative inside do? If it's a negative, it reflects. How does it reflect if it's on X? It reflects it sideways. Okay? What does the 2 do? It makes it stretch or shift. Squish. It's a squish, so it's even more narrow, yeah? Then what does that negative do? Reflects it down, so now it's back to this kind of shape. You with me? And then finally, then I'm going to take this shape that I'm doing in hard blue and move it. Now, how do I move it, or where do I move it? Right 3, up 1. So if I go to this essential point that was at the origin, go right 3, up 1, then I have a steep growing cube like that. That's my final answer. I'm going to dump all my extra stuff and label my essential point. What is it? 3, 1. Does that check? If I put in 3 into my equation, what do I get? I do get 1, so at least it's in the right place. I don't know about the bend. I could do the y-intercept if I wanted, but I don't think they ask. Do they ask? No. All right. All right. Little more U now. What should I do in B? Factor. When you take out, what do you take out? What are you left inside with? 1/3 or 3? 3. Okay? Now, we've got it factored. Now let's talk the process. The basic shape of absolute value is V. And that V normally is a line with a slope of 1 unless you change it. In this case, we've got a 1/3 in front of that. So is that a horizontal stretch or squish? Stretch. So now you can think of the slope as 1/3 now. So now we're even wider. And again, I'm going to do the stretches and reflections first, and then I'm going to do the shift. So I did the stretch, now I'm going to do the reflection. What does that negative do? Reflect it side to side or down? Down. So now I've got wide opening down. That's my shape. Now I need to figure out where to put it. Now do the shifts. Where does it get shifted? Right, 3 up 1. So I've got a wide V shape with an essential point of 3, 1. You with me? No, but it would be a doggone good checkpoint. What do you get when X is 0? Yeah, I agree. 0. Okay. So it seems like we've got it nailed, yeah? All right. Last one. Log graphs are going to take a little longer. Still have to factor it. Log of the negative of x minus 2. All right. So now let's talk the 2 essential points and how they get moved around. So what's the natural log graph look like normally? Goes through 1, 0 and base 1. So unchanged, and I'm talking real life, just pencil. Yes, question.
Why was the -1 inside multiplied by 3? Isn't the 1/3 already pulled out?
Are we looking here or
B.
B? What about it?
Why is the -1 multiplied by 3 on the side? Isn't the 1/3 already?
Oh, that's a. Are you talking this? Is that what you're referring to?
So it's 1/3 x minus 1. Then right below you have 1/3 of x minus 3.
Yeah, that's because I factored out a 1/3 from both of these. It has to go out of both. So when you take a factor of 1/3 out of 1/3 x, it's x. But when you take a 1/3, when you divide 1/3 out of 1, that's where it's used.
Was it not already factored?
No, that's not factored. Factored is so when I say factored, I mean the x has a coefficient of 1, nothing else. No negative, no 2, no nothing. And so the factoring really comes from saying, I need to take something out so the x coefficient is 1. That's a great question. I didn't even think about it. I could see how you could think, well, okay, it's kind of already factored. I see what you're saying. But when I say factored, I mean the x needs to be 1x. Thank you. Good question. Those are the kind of questions that I'm going to clarify. All right. So that's the shape, yeah? What is that negative? We're going to first change the shape, then shift it around. So what does that negative do? Side to side or up and down? Side to side. Beautiful. So this point, now it's going to be negative 1, 0. This will be negative 2, 7. Or negative 2.7, rather, 1. And now we're going to shift it. How do we shift it? Right, 2 and down 3. All right, so what would be easiest, to shift this point here? Okay, so if I shift this point right 2 and then down 3, where does that put it? 1, negative 3, I agree. Okay, let's just call this 2.7 rather than 8. I think it'll be easier. What do you think? So this is negative 2.7, and we're going to go right 2. So negative 2.7 plus 2 is negative 0.7 or positive 0.7? Negative 0.7, and then down 3 is to negative 2, yeah? So what is that new point? Feel free to call it the 0.7 if you like. Negative 0.7, and the y, negative 2. Okay? All right, and then what about the fence or the asymptote? It was right at the axis, but it got shifted 2 to the right. Does the down 3 mean much for something that goes forever up and down? No. So just the right 2 is what matters. So our shape should be down like that. You with me? So the asymptote was at the axis. In the original, it was at the axis. When I reflected it, it was still at the axis. And so then if you move it right 2, it ends at x equal 2. And I should actually have written the asymptote. Do you agree the asymptote is at x equal 2? Okay, cool. Try the first one on your own, and let's see how we do. So first check that you factored it correctly. You should have 2 negatives and 1 negative is inside the squaring, yeah? Okay, so this first negative, what does it do to the graph? Side to side, which puts it exactly in the same place. Do you agree? What does that negative out front do? Up and down. So that now it's there. Okay, that's all my shape changes. Now let's talk shifts. How is it shifted? Right, 3 up 2, so it should be a critical point or essential point at 3, 2, and opening down. How'd you do? Yay. Okay, try 2. Bless you. Yes, horizontally shrinks it, which actually, when you horizontally shrink a V, actually makes it look taller. Okay, so that two part is funky. It's a horizontal squish, which makes it look like a vertical stretch. So hopefully, do you have the two is a narrow V. It's narrow. Okay, what does the negative do? Upside down. So we have a narrow V upside down, and now we shift it. How do we shift it? Right, 4, 3. So do you have a narrow V with an essential point of 4, 3? Okay, cool. Try number 3. I want to eventually get some logs and exponentials, but we'll work. Yeah, talk over to the Eagles. All right, so let's talk the 4. The 4 is a horizontal squish, so it should make it look vertically stretched, yeah? So the 4 would look like that. Then what does the negative inside do? Side to side or up and down? Side to side. And what does that negative do? Up and down. So after all the changes, the 4, the -4, and the -4, this is where I'm at now. Now I shift it. How do I shift it? Right, 1 up, 1. So hopefully you have something like an essential point of 1, 1, like that. Do you? Cool. Can we get some, what about, should we go over, is this something and I'll do this together, or do you want me to just let you go? Together. Okay. If you feel like I'm killing this, you want to plow it without us, go for it. But if this is working for people, let's do it. 4, go for it. Start with the shape, then do the negative, then do the 2 and the 3. You good, Pete? You can go on the back if you're killing it. You check your work when you go over there. Listo? See? Okay, so what's the shape of 1 of the x? 1 over x. This deal here. Okay? What does the negative do? Instead of first third, the negative makes it second fourth. Okay, we do our reflections, then we do our shifts. What shifts? Left 2, up 3. You have asymptotes at y equal 3 and x equal -2. And then shapes in the upper left quadrant and the lower right quadrant. Yeah? Cool. Okay, now let's get some exponential action. This is where you do great. Okay, question?
When the negative is on the outside, it's on like the function itself. The function is one. So when it's outside, you can change it one function. When the negative is in on the x,
I mean, that is the great answer, but the shape.
These are the hard ones because they require 2 points, and that second point is just a mother, especially when it's E. So it gets better. What about the negative? Does it reflect it side to side or up and down? Up and down. So now the critical points will be at negative y of 1 and negative y of 2.7 here, yeah? And then the shifts? Right 1 up 2. Let's start with the easy one. This point is easier. Right 1 up 2 puts it there. What is that? 1, 1. Okay? Now this point, right 1, let's start. This was, what? 1, negative 2.7. Do you agree? All right. So when I go right 1, what does that put it at? 2, negative 2.7. And then up 2, it's right there, yeah? So what is that point? 2 is negative 2.7. We added 2, negative 0.7. Okay? What about the asymptote? Track where it was. Wasn't it here to begin with? And then when it reflected, it was still here. And then everything got shifted right 1, which did nothing, but up 2, which puts it at 2. So what's the asymptote? X or Y? Y equals 2. All right. That is, now my graph is a total mess. I hope you're erasing a little bit of the old system. Yeah. You can. Does that help?
No, I
Does
always
that
do it
work
first
better?
and then I get it wrong.
Oh.
Like I always shift.
You shift? Oh, yeah. No, if you shift first, then you will get it.
Okay.
So, yeah, you
So
need
you
to
have to.
change the shape first, and then shift it around.
Okay.
Okay. Yeah. But we already got the hard ones done. The rest is matching, so you're not actually graphing. So the inside should be pretty good. Do you want to go to matching and try some of those?
No, she just finished the last one.
All right. All right. Log ones are tough. So what's log base 2's base graph? 1, 0, and 2, 1. Okay. What does the, now we're going to change the shape. So negative causes it to go down because it's outside. So now that point, the 1, 0 point still at 1, 0, but the other point, instead of being at 2, 1, is at 2, negative 1. Right, exactly. Yep, sorry, I was a little slower. So then what are you shifting it by? Left 1, up 3. So if you take that 1, 0 point and go left 1, up 3, where is it in? 0, 3. And if you take this point, which was 2, negative 1, and go left 1, up 3, it goes to 1, and up 3 takes it to? You tell me. It was at 2, negative 1. We went left 1, so that puts it at 1, negative 1. Then we go up 3, which puts it at 2. So 1, 2, yeah? You with me? All right, where's the asymptote? Negative 1, what's the full equation? X equals negative 1. That's a humdinger. Let's do one matching just for fun. Number 7. Which of those graphs, A, B, C, or D, matches it? What's the change going on? No. Too late. Yeah, x equal negative 1. No, there's not a horizontal asymptote. Logs go forever up and forever down. Okay. So what do you say? Left 2 or right 2? Left 2. Narrower or normal width? Normal width. So you say B or D? B, boy. B. All right. That should get you started. You're on your way. Everything's going great. Today you're already getting better. Tomorrow you're just going to be the master. You're going to be teaching this class next year. Am I right?